Purification of colloids. The process used for reducing the amount of impurities from colloidal solution is known as purification of colloidal solution. One important method used for purification of colloid is dialysis. It is the process of removing a dissolved impurities from a colloidal solution by means of diffusion through a suitable membrane. In this method, a bag of suitable membrane containing the colloidal solution is suspended in a vessel through which fresh water is continuously flowing. The impure molecules and ions diffuse through the membrane into the outer water and pure colloidal solution is left behind. Here, dialysing membrane allow only the movement of impure molecules and ions from back to the outer water. But the membrane will not allow the movement of colloidal solution from back to the outer water. The next method of purification of colloid is electrodialysis. This method is just like a dialysis process. In this method, movement of the impure ions across the membrane can be increased by applying electric current through two electrodes. This method is very fast and is called electrodialysis. Let's see the figure. In this method, the colloidal solution is placed in a bag of suitable membrane while water is taken outside. The electrodes are fit in the compartment. The impure ions present in the colloidal solution migrate out to the oppositely charged electrodes when we apply electricity through the solution. So, I repeat again, when electricity applied in the solution, the impure ions from the bag move to the oppositely charged electrodes through the membrane. The last method of purification of colloid is ultrafiltration. Ultrafiltration is the process of separating the colloidal particles, that is dispersed particles, from the solvent and the soluble solids present in the colloidal solution by specially prepared filters which are permeable to all substances except to the colloidal particles. The colloidal particles left on the ultrafilter paper are then stirred with the fresh dispersion medium to get a pure colloidal solution. The ultrafilters are prepared from ordinary filter papers by reducing their pore size by impregnating them with the collodion, which is a 4% solution of nitrocellulose in a mixture of ethanol and ether. Ordinary filter paper is soaked in collodion followed by hardening with formaldehyde and then drying it. Thus, by using ultrafilter paper, the colloidal particles or dispersed phase are separated from rest of the materials. Properties of colloidal solution. Tyndall effect. A colloidal solution can be distinguished from a true solution by its ability to scatter light. The scattering of light by colloidal sized particle is called the Tyndall effect. This effect was first observed by Tyndall in 1869. A strong beam of light was passed through a colloidal sol placed in a dark place. The path of the beam got illuminated. The illuminated path of the beam is called Tyndall cone.
Every morning, we can see sunlight shooting through the window. This natural phenomenon is due to scientific theory known as Tyndall effect. But what is Tyndall effect? In this video, we are going to conduct a simple experiment to demonstrate Tyndall effect.
Here's a list of apparatus and materials used in the following experiment: plastic bottles, a teaspoon of milk, clean water, and a laser pointer. Here we have 2 bottles filled with water. As you can see, the laser path is not visible. But after you add in a few drops of milk, which acts as the colloid, the path can be seen clearly in the water bottle spiked with milk, while no visible light is seen from the clear water. So our next question is, why light is deformed passing through water spiked with milk? Once again, this is due to the Tyndall effect.
Tyndall effect is observed only when the following 2 conditions are satisfied. The diameter of the dispersed particle is not much smaller than the wavelength of the light used, and the refractive indices of dispersed phase and the dispersion medium differ greatly in magnitude. Brownian movement. The zigzag movement of the colloidal particles is called Brownian movement. Let's see the figure given below. The Brownian movement or zigzag movement is due to the unbalanced bombardment of the dispersed particles by the molecules of the dispersion medium. The Brownian movement has a steering effect which does not permit the particles of colloid to settle down and thus give stability to the colloid.